Embracing uncertainty is a cornerstone of artificial intelligence. Uncertainty is an inherent aspect of the real world. We encounter it daily in various forms, from unpredictable weather patterns to fluctuating stock markets. For humans, navigating uncertainty is second nature, informed by our experiences, intuition, and ability to reason with incomplete information. However, replicating this nuanced handling of uncertainty in artificial intelligence poses a significant challenge. Traditional AI systems, often designed for deterministic environments, struggle when confronted with ambiguity and unknowns. This is where uncertainty modeling comes into play. It is a fundamental pillar of robust and reliable AI, enabling systems to acknowledge the limitations of their knowledge and make decisions in the face of ambiguity. Instead of providing definitive answers, uncertainty-aware AI systems quantify the confidence or lack thereof associated with their predictions. This shift from deterministic outputs to probabilistic reasoning is crucial for building trustworthy AI that can effectively operate in complex, real-world scenarios. Imagine a medical diagnosis system that can express its level of certainty in its predictions. Instead of simply stating a diagnosis, it could provide probabilities. There is a 70% chance of condition A, a 20% chance of condition B, and a 10% chance of other possibilities. This probabilistic output empowers medical professionals with a more comprehensive understanding of the AI's reasoning, allowing them to make better informed decisions. Uncertainty modeling, therefore, is not about eliminating uncertainty altogether, which is often impossible. Instead, it is about representing, quantifying, and reasoning with uncertainty, allowing AI systems to operate more effectively and ethically in an uncertain world. Navigating the unknown involves various techniques for uncertainty modeling. These techniques, drawing inspiration from fields like statistics and probability theory, provide a framework for representing and reasoning with uncertain information. Probabilistic models, a cornerstone of uncertainty modeling, represent uncertain quantities as random variables with associated probability distributions. These distributions capture the likelihood of different outcomes, allowing the AI system to quantify its confidence in its predictions. Fuzzy logic, another approach, deals with uncertainty by allowing for degrees of truth rather than strict binary values, true or false. This concept is particularly useful in scenarios where boundaries between categories are blurry or subjective, such as defining tall or cold. Gaussian processes offer a powerful non-parametric method for modeling uncertainty over functions. They are particularly well suited for tasks like regression and optimization, where the goal is to learn a continuous relationship between input and output variables. Monte Carlo methods provide a versatile set of tools for approximating solutions to problems involving uncertainty. By repeatedly sampling from probability distributions, Monte Carlo methods can estimate complex quantities, such as the expected value or the probability of rare events. These techniques, while diverse in their mathematical underpinnings, share a common goal to equip AI systems with the capability to represent, quantify, and reason with uncertainty. By incorporating these techniques, AI developers strive to create systems that are not only intelligent but also reliable, transparent, and robust in the face of real-world complexities.